Hello there, my name is David Jeffrey, and I tutor chemistry and organic chemistry in Wyzant. So a student has asked this question: how many moles of oxygen gas are consumed if 8 moles of hydrogen are used to form water? And what I've done before recording here is I have sketched out the balanced, right? The mass balanced equation, chemical reaction equation that corresponds to this chemistry, right? The formation of water from hydrogen gas and oxygen gas. Um, so you must work with a balanced equation. Don't ever do anything with an unbalanced chemical reaction equation in terms of balancing mass and balancing moles. And what I've done here is I would tend to write the first one. I would tend to write it this way, right? 1 mole equivalent of hydrogen gas reacts with 1/2 mole equivalent of oxygen gas to give 1 mole equivalent of liquid water. Now, I don't know what you've been told, but I will tell you right now, I promise it's true, that there is nothing wrong with writing fractional stoichiometric coefficients. Nothing at all wrong with that, because we're not referring necessarily to 1 molecule of hydrogen and 1/2 a molecule of oxygen, because you can't have 1/2 a molecule of anything. We're referring to mole equivalents. We're referring to trillions and trillions and trillions, right? A huge ensemble of these molecules. So there's nothing wrong with writing a fractional coefficient. Now, there's a lot wrong with writing a negative coefficient, but there's nothing wrong with writing 1/2 O2. But if you don't like the way that looks, and if it makes you uncomfortable and interferes with your sleep patterns, then by all means, just double that reaction to get 2H2 plus 1O2 gives 2H2O, because the only thing that matters is the mole ratios. It's not the absolute mole quantities. That's not what the coefficients represent. They represent relative mole ratios. And so if 8 moles, if 8 moles of hydrogen, if 8 moles of hydrogen are consumed, so that's what we're told. So let's put that in, and we'll use, I guess, pink, right? So if 8 moles of hydrogen, an absolute quantity now in an actual procedure, are used to make water, the question is how many moles of O2 stoichiometrically are consumed? Well, you can see the answer is very simple. It's 1 to 2, which is what 1 to 1/2 is, or 2 to 1, same thing. So the answer is 4. The answer is 4. There are 4 moles of oxygen gas consumed for every 8 moles of hydrogen in an actual procedure. And then, of course, we are talking about absolute quantities, but we're always using mole ratios. So whether you use the top or the bottom, it doesn't matter, but you must use a mass balanced equation. Okay, so hopefully that answers the question. And I hope to see some of you in my Wyzant tutoring room. Take care.